Okay, guys, today we're going to continue with our solving equations, and let me get back to the first page here. And what we are going to do when we solve equations today is we're going to add decimals in there. So none of our properties are going to change, none of your work is going to change. You still have to solve the equations the same way. The only thing is that we're going to add decimals in there. The one thing I do want to go over is I want to remind you guys how to add and subtract decimals. You are required to add and subtract decimals without a calculator. As far as multiplying and dividing decimals, we can use calculators for those, so I'm not going to go over those. You would just use a calculator. When you're solving equations, you can use a calculator for your adding and subtracting, that's fine. But as an example one, you can see right here, we will have a couple questions that you need to solve without a calculator, and so you need to make sure you know the basics of adding and subtracting without a calculator for your decimals. Hopefully you remember in example one here, adding and subtracting decimals. Hopefully you remember kind of combining our decimal rules with our integer rules. But with your decimal rules, you must line up the decimal point. So your place values must be lined up. So in example A here, I'm going to have negative 14 and 2/10 plus, and then I'm going to have a negative 17.6. Now since they are the same sign, they're both negatives, I'm actually going to add them together. So because I add them together, 2 plus 6 is 8, decimal point moves straight down, 4 plus 7 is 11, put the 1, carry the 1. 1 plus 1 is 3. And since they're both negative, your answer is negative. Remember when you're adding integers, that two negatives continue to be negatives. That's a multiplication where they become positive. So your answer is negative 31.8. I lined up my decimal point. Place values lined up. I had my tenths over tenths, ones over ones, and tens over tens. Okay, in example B, I'm subtracting. Since I'm taking away more than I have, okay, I'm really going to turn that into a plus negative 12.5, so 4.7 plus negative 12.5. Since they're different signs, I'm going to end up subtracting them, and I'm going to put the bigger number on top. So I'm going to put 12.5 on top, and I'm going to subtract away 4.75 from that. Now, when I line this up, remember, I have to line up my ones. 2's in the ones, 4's in the ones. Decimal point, 7 is in the tenths, 5's in the tenths, and then I have to put a 5 here. And I must put a 0 there because I need a place value, a placeholder there. Now I can subtract these numbers. The 0 is going to become a 10. I got to borrow, and the 5 becomes a 4. 10 minus 5 is 5. I cannot do 4 minus 7, so that's going to be 14, and I need to borrow from the 12 or the 2 and make it a 1. 14 minus 7 is 7. Decimal point moves straight down. Can't do the 1, so I need to make that 11 and borrow, make that 0. 11 minus 4 is 7. Now, I had negative 12.5. That was one on top here. So I have more negatives than positives. So my answer is negative 7.75. I took away more than I had if you think of the original problem. Okay, if you need to copy that down, go ahead. I'm going to move on to my next slide. Now we're going to start solving equations. So when you solve equations, remember, you have to do the same thing to both sides. You always want to work with the side that the variable is on. So that's the side that we're starting with. That's the side we're working with. When we're adding or subtracting, you must do the same thing to both sides. And so in the first example, I have 12.6 plus m equals 9.2. I'm adding to my variable, but I remember I want to get my number to 0. That's going to get the 0 plus m. Then I can use my additive identity property to answer that. So I'm going to subtract 12.6 from this side. I'm going to subtract 12.6 from this side. That is going to be m equals. Now I can look, and when I look at this, again, I'm taking away more than I have, so I'm really going to do 12.6 minus 9.2, and that's going to give me 3.4, and since I'm taking away more than I have, that's going to be negative 3.4. Alright, so if I were to show that over here, 12.6 minus 9.2, that's going to be 3.4, and then I took away more than I have. For the equations part, you can use a calculator to get you through that part. For B, I have r minus 2.3, or 2 3/10, equals negative 1 7/10. Okay, I'm subtracting 2.3. The inverse operation of subtracting is to add, so I'm going to add 2.3 to both sides, so I do a plus 2.3. Don't forget, you must show your work. You must show that work on all equation problems all year. You must show. Okay? Oops, I forgot the word show. Must show work. Alright? That's going to get rid of those or get to 0. R minus 0 is just R equals. Again, I have different signs here, so I'm going to subtract them. And when I do that, I have more positives than negatives, so it's going to be 0.6. If you need to, you can do it off to the side. 2.3 minus 1.7, you can borrowing, and you get 6, 0, there you go, and the positive number is on top because it was bigger. Okay, so R equals 0.6. Okay. If you are done, I'm going to pause, so if you need to, or I'm going to move on. If you need to pause, go ahead. And continuing, this is still example 2, solving equations. Okay, in example C here, I have negative 12.2 t, which means I'm multiplying. The opposite of multiplying is divide. So I'm going to show division to both sides and divide both sides by 12.2. You can definitely use a calculator for these. And I'm going to get t equals, well, my answer is going to be negative, and then when I divide that, I get 0.8. T equals negative 0.8. For example D here, I have c divided by negative 4 equals negative 10.5. This is division, so remember I show my work by multiplying, and I show this off to the side. You can show it using a dot, or you can use parentheses, so I'll show it both ways. You can mix them if you want. Typically use consistent symbols, but whatever you want. And, oops, let's make that a negative 4, because that's a dividing by negative 4. And so those are going to cross off. Negative 4 divided by negative 4 is 1. That leaves me with c equals. And then negative 10.5 times negative 4 is positive 42. And so I get c equals positive 42. Remember, in all these examples, you could go back and check your work by plugging 42 in for the variable and seeing if you get the same answer. Okay? Once again, don't forget to show your work. Okay? You need to show this step, the solving equation step, in every problem. Okay, I'm going to move on. If you need to pause, go ahead. Otherwise, we got our last example. In our last example, we're going to be writing and solving an equation. So here we have, when a chipmunk hibernates, its weight decreases by about 0.31 pound. After hibernation, a chipmunk weighs 0.35 pound. Find the weight of the chipmunk before hibernation. So in this problem, what we want to think about is kind of a timeline. So when I'm thinking about this chipmunk, we got its starting weight minus how much it loses, and that's going to equal its ending weight. So that's kind of what I'm thinking about as my numbers. So since the question says find the weight of the chipmunk before hibernation, that would be how much it started at. I don't know. X. Minus how much it loses. It says it decreases by 0.31. So I'm going to put 0.31. And then it says after it weighs 0.35. Okay? It did not lose 0.04 or anything like that. You got to do the work to find your answer. That's my equation though. And again, you want to write equations so that you have to either add, subtract, multiply, or divide to finish the problem. In this case, I'm going to add since that's a subtraction problem. So I'm going to add 0.31 to both sides. They're both positive, so I'm going to get x equals 0.66. And then I have to think about, this is a word problem. What is my final answer? This is going to be 0.66 pound. That's how much the chipmunk weighs. Okay, so about 2/3 of it, well, not even, 2/3 of a pound. That's a pretty light chipmunk. Okay, less than a pound. All right, and that's it for today. Have a wonderful night, and I will see you guys all tomorrow in class.